It's great to have you join me today. I think I need to adjust the camera a bit. Yeah, I think it's better this way. Awesome. Okay, it's great to have you join me today. This is a continuation of the class MTH 105. Let's see if I can shift this back a bit. Adjust the camera, it can fit well. Okay. I think it's not balanced here. Trying to see how I can fix this. So this will be balanced. Moment. Okay, I think it's better this way. Yeah. So I'm just gonna send the link to the class right away while we wait for them to join us into this class. I'm just gonna do that quickly. Share. Okay. Okay. I think the link has been shared and waiting for others to join. So we can just go ahead with tonight's class. So still a continuation of MCH 105, Mathematics for Management Science, and today makes it our fifth class. So you're gonna be using the Cramer's rule. Cramer's rule. Awesome. We have some persons with us already. I don't know. Please do also introduce yourself so we can know you and where you're from, the department, your name. So without wasting much of our time tonight, just gonna get into business straight ahead, and today we'll be solving matrices using the Cramer's rule. So first example, illustration 1, we're going to be taking this example. X plus 2y equals 3. 3x plus 4y equals 1. So this is a question from the material. We're going to be taking this first. So this has been a journey so far. We've treated determinant of matrix, we've treated inverse of matrix, we've treated addition, we've treated multiplication. So today is all about using the Cramer's rule, and just like every matrices and the has an implication of the rule, so does Cramer rule has too. So for today, we're solving something like this for the first illustration. I'll be having something much more than this as we proceed. So then we may say, to solve this, the first thing foremost is that this is going to be solved in a matrix form. So we need to make this a matrix. Now it's not in the form of a matrix. So now we need to make it a matrix. So then we may say, to make this a matrix, we say x standing alone, we're going to give it 1. 1 is going to be the coefficient of x. And whatever, okay, I think it's just x here standing alone. This is 3x, this is 2y, this is 4y. So we're going to make it a coefficient of x will be 1. Then we have 2. Then we have 3. Then we have 4. Now we have made it a matrix. So from here, we can tick it up. Oh, Mr. Daniel, it's great to have you join us tonight. I don't know why Mr. Jolas is not here by now, but it's great to have you all say, Mr. Daniel. So we are using the Cramer's rule to solve this equation. Okay, now, so this is the Cramer's rule. It's still matrices. We are still doing matrices, and this is an MT205. So we are using the Cramer's rule to solve this equation. So Daniel, are you with us? We are using the Cramer's rule to solve the equation. Let me adjust the camera so you can see it clearly. Okay, I think that's clear enough. So now, this comes this way, x, then y, then we have this 3 and 1. I'm here already. Okay, also, Mr. Jolas, great to have you. So now, what I just have there is an interpretation of what is up here. This is, we said we are going to give x a coefficient. So we give x 1. Then this x here already has a coefficient, which is 3. Then we bring down the 3 here. Then these 2 will bring it down. The 4 will bring it down. Now let's not forget this is x here. We bring it down. The y here, bring it here. So this equals to, then it comes here. Now, so let's proceed from what we have here. Now the first thing foremost to do is to find the determinant of this matrix. Is to find the determinant of this matrix. And how do we do that? We then say, oh, my marker is fading. Switch to the other one. Okay, I think this is better. Now to find the determinant of this matrix, we represent it with this sign. We then say, we then do this. This multiplies this, and this multiplies this. Let's not forget the first thing we are doing after we have interpreted this equation, we have interpreted it into this, turned it into a matrix. Then the next thing we are doing is to solve for the determinant. This matrix will solve for the determinant. Then we say to solve for the determinant, this multiplied as 1 multiplied 4 minus this multiplies this, 3 multiplies 2. Then we say this is 4 minus 4 minus we have this is by 6. So we may say we have positive 4 minus 6, so we have minus 2. So the determinant for this matrix is minus 2. So we have that. So let's keep that here. Okay, how did we get the 1? Thank you for the question, Mr. Daniel. As you can see here, this x is standing alone. If it happens to be that this y is also standing alone, or if it happens to be that this y here is, or if it happens to be that all these elements if it happens to be that all these elements are standing alone, then automatically for us to interpret this into a matrix, then we'll all give them a coefficient. Do you understand that? In a case like this, they would have in a case like this, they will have something like this. In a case like this, they will have something like this. We have one, we have one, we have one, we have one. So that is the rule of, that is the Cramer's rule. If this is coming like this, then for us to interpret it, then it has to be this way. So I don't know if you are together. Mr. Daniel, is that clear enough? Mr. Daniel, is that clear enough? Okay. I think I lost the connection there for a moment. Okay. So yeah, I think we're back. So I can just can put this back. This is x to y. Then this is 4y. So 3x. So we can say 1, 3, 2, and 4. So so we are going to just keep our answer somewhere here, equals to -2. So now that we have that, then we are going to solve. We are going to solve for x. We are going to solve for y. Let's not forget x, y. We are solving for the two of them. So let's erase this. Now it's going to be the determinant for x equals. Now, to get for x, here's what we're going to do. This is our matrix, and this here, this row, and this column represents x. So we are going to move the elements in here to represent x, and we are going to sustain this. Now this is it. Let me put that into play. We're going to do it this way. This is going to be substituted with this, which is 3 and 1, and this remains because this is y. These are the coefficients of y. So we have 2, we have 4. So then we may say x equals, this goes down and this goes up, 3 into 4 minus 1 into 2, then we say equals 3 times 4, that should be 12, minus 1 times 2, that should be 2. So the answer now is a positive 12, this is a negative 2, the answer should be 10. So for x, we have our answer as 10. Okay, I think I've chopped off. Yeah, I think it's better. Okay, I think I've chopped it up a bit. With the camera. Oh my goodness. Trying to fix this first. Yeah, I think it's better this way. So now we've done for the determinant of the initial matrix, we got -2. Then for determinant for x, we have 10, which is this. So we are going to solve for y. So now for y, so for y, in case of y now, this is going to remain. The coefficient of x is going to remain. So we'll put 1, then 3, and this is going to be substituted for this, which is 3 and 1. I think I'm losing the marker. Is it understood? Is it understood? Okay, Mr. Jolas, I'm just seeing your question. Say, can we add any number? No, you can't add any number. It has to be 1. If you see any element like this, the only number you are permitted to add is 1. There's an invisible 1 here. That is the only number you are permitted, not any number. It has to be 1. So now, Mr. Daniel said it's not clear. Now, let me do this. This is the question. This is a question. And the question says x plus 2y equals 3. 3x plus 4y equals 1. This is an equation. So for us to interpret this into a matrix, then we are obliged to do this, which is this x has an invisible coefficient, which is 1. All this will be eliminated in order to form a matrix, simply interpreted as 1, 3, 2, and 4. This has just been interpreted, but it's not complete yet. So we have x and we have y. You know, we eliminated behind the element, we eliminated x, we eliminated y, x, y. So this x and y is brought down here. Okay, now it says that's a question from Mr. Daniel. I said, what does Cramer rule says for us to know that it's Cramer rule? Now, for any question given to you, it will be specified that solve the following equation using Cramer's rule. Just like the way we have it in the material here, I think you can come to page where's the page number? Okay, please, if you have the hard copy of the material, I know you are streaming now from your phone, but if you have the hard copy, you can come to page 45. In page 45, we have are we together? Page 45, where we have Cramer's rule to solving equations. If you're out there, I think it's on page 45. Immediately after I think it's I think it's immediately after application of determinants. When you scroll down, then you see application of Cramer rule in solving equation. So now, whenever you are given the other rules, so whenever you are given a question as this, and you are told, okay, yes, also on page 45, and you are told to use Cramer rule. The process we are doing is exactly the Cramer rule process. It is the rule that states that the first thing is that we have to first interpret this equation into a matrix. We have to create this is not in form of a matrix. This is an equation. And a matrix is different, an array of numbers. That is what a matrix is. Array of numbers. But this is an equation. That's why I put it in red. I circle it in red. So now, to interpret this into a matrix, the first thing we have to do is to do this. And x here doesn't have anything standing alone. So we give it a coefficient, which is 1. Then 2y here, we bring down the 2 and keep the y somewhere. Then 3x here, we bring down the 3 and we keep the x somewhere. Then we bring down the 4, which is the 4 here, and we kept the y somewhere else. So now this x here is standing in place of all the x we have here. And the y here is standing in place of all the y. We have 2y, we have 2x. So that we have this. Then this equation is equals to 3. Then this is being brought down, which is 3 and 1. Okay, great. Mr. Ajola said great. So that's how it works. That is the rule. This is the first thing. And this is the first thing. This first thing we have done now makes the work easy for us. This is just, this is a 2x2 matrix. We are going deeper as we are going to take a 3x3 matrix very soon. So now let's just go straight into it. I believe it's well understood now. Okay, nice one. We have who is the third person with us? Please do well to say hello so we can know you and know you're with us. So now so as I said earlier, the first thing after we have done this, the next thing to do is to solve for the determinant, which is this, and we have done that. And how did we get determinants? We said for the determinants, let me do that here quickly. Let me just so that we will get the progression of everything. So this is the first thing after we have been given this question. So the next thing to do after this now is to find the determinant of this matrix. So we then say this sign is signifying that we are looking for the determinant. This sign could be, you can use D determinant. It doesn't really matter. If you understand that what you're looking for is determinant, then that's all good. Then we say this multiply this multiplies this. So we have 1 into bracket 4 minus 3 into bracket 2. Now this gives us 4 minus 3 times 2 is 6, which is equals to, this is positive 4, negative 6. So by the time you are paying somebody, you are owing 6 naira, it's going to remain 2 minus 2 naira that you are owing. So now, that was how we got our determinant as this. So now we have that as that. Then after we have gotten the determinant, they will now look for the determinant of x and y. So to get the determinant for x, let me put that here. So to get the determinant for x, we then say I don't want to erase this. Let me just try and adjust the camera so we can see what we have under, because I really don't want to erase that. When we have 6 minus 6, that will be 0. Mr. Jolas, that will be 0. When we have 6 minus 6, that will be 0 straight up. So then we may say, and this is for determinant. Now determinant of x, then we have For x now, we have, let's not forget, this is the row, this is the column for x, which is 1 and 3. So this is going to be substituted. Oh, my laptop's light is running low. I think I need to increase that a bit. Yeah. So now, for us to get the determinant for x, I think I'm mixing this up. Let me just take this so I can x. So the coefficient of x is going to be substituted, which is 1 and 3. This 1 and 3 will be substituted. Then it will be represented by 3 and 1, which is this here. I think I need to adjust this camera so we can see both. Awesome. Yeah, this is great. So now, the determinant for x, the coefficient of x, which is 1 and 3, will be substituted for 3 and 1. Now, instead of us to have 1 and 3, since we're looking for x, it's going to be 3, then 1. This 1 and 3 is substituted for 3 and 1, which is here. Then y, 2 and 4 is going to stay, which is 2 and 4 is going to remain. The same thing will be applicable to y too when we're looking for a determinant of y. So this one multiplies this, and this one multiplies this. So we come here, we then say 3 into 4 minus 1 into 2. That gives us 4, that should give us 12 minus 2. So now positive 12, that should be 10. So dx is equal to 10. So we have arrived at our answer for this. Now, to solve for, and then we can see this dy, then we say yeah. Now the same thing we did to x, that will substitute the coefficient of x. We are going to substitute, this is the coefficient of x we substituted for this. We are going to substitute the coefficient of y as well, and it will be substituted for this. So instead of this 2, 4, it's going to be 3, 1. So x is going to remain 1, 3. Now it's going to be 3 and 1. So this multiplies this, and this multiplies this. So we have dy, that's a 1 into 1 minus 3 into 3. Let me check if anybody has. I think we lost the connection there. Okay, Mr. Dennis has explained why again. I don't know why this is the wrong time for anybody to call me now. There was a call that came in, and that was what disrupted the connection. So he said I should explain the why again. Mr. Daniel, I got your question. So what happened to x is what we are repeating for y as well. It's just that the only thing we switched was the coefficient of x when we were doing for x, and the same thing is applicable to y too. Now this is for y 2 and 4. We are looking for y. It's supposed to be 2 and 4 here. Now this matrix here, which is the D, this coefficient are for x and this coefficient are for y. So now when we're looking for the determinant of x, the coefficient of x was switched with this. What the equation is equated to, which is 3x and y is 3 and x and y is 1. So what the equation was equated to was what we substituted with the coefficients of x, which is this. So now, the same thing is applicable in the case of y. The coefficient of y is substituted to what the equation is equated to. So then, instead of 2 and 4 being here, 2 and 4 being here, it was substituted with 3 and 1, which is what the equation is equated to. I don't know if that is clear enough now. It's the same thing we did for x. And this is for x. And that's x. And this is y. Okay, great. Awesome. I think Mr. Daniel, we are on the same page now with Mr. Daniel. That's awesome. So we can move on very quickly because we still have some other things to do. Can you make it 1 and 3? I'm not sure I understand that question. I'm not sure. When you said 1 and 3, I'm not really sure I understand that question. Please put it in a clearer form. In a clearer form. So now let's just continue. For y, we have 1 times 1, that's 1, minus 3 times 3, that is 9. So positive 1, negative 9, that gives us negative 8. So we have, okay, I think we have that as that. Okay, now, so we have x is 10. So we have y as minus 8. Minus 8. So we can just erase this while we so this is just the second step. There's one last step. There's one last step we have to observe, and the one last step is, let me write this here. This is equals to minus 2. X is equals to 10. I think we are done with this now. Can let go of this. Or minus 8 here. And y is equals to minus 8. So the last thing we are doing is a formula which says determinant equals to the determinant of x all over the main determinant. Now, this is for x, so we are going to use the same determinant for y and over the same determinant. So we have determinant for x, which is 10 all over minus 2. Then we have minus 8 all over minus 2. You have this. So this divided by this gives us minus 5, and this should give us 4. I think yep, I think it's better that way. So now we have our final answers as, so now x equals to minus 5, y equals 4. So now to check, I don't know if we are together up to this stage. So since, let me just write this quickly. since x is equals to minus 5, then y is equals to 4. Then let's check something. So I think, is it clear up to this extent? Is it clear enough? Okay, come again a bit. The caution. Okay, Mr. Jola said okay. Okay, Mr. Daniel said I should come again. So now this is the formula for x. This is the last step. Let me check. Okay, Mr. Jola said great, awesome. So for x, to get your final answer for x, you divide x by the main determinant itself, which is minus 2. You know, we already said x is 10, y is 8. So to get the main determinant, to get what your final answer for x will be, then you have to divide this by this, which is 10 divided by 2, which is equals to 5. X is equals to 5. Then y, this is the formula, which is the determinant of y divided by the determinant itself, which is minus 8 divided by minus, which is 4, equals to 4. So I believe that is well understood. We can move to the next example, which is going to be a little bit in depth than this. So I want us to be done with matrix today. Also, so this now I want us to be done with matrix today, so that in the next class we can take something else, maybe arithmetic progression or geometric progression or something different, because we need to move at the speed of lightning so we can catch up with a lot of things. Just need to wipe the board very quickly. So we are done with illustration 1, and now this is illustration 2, which is going to be a bit in-depth, a bit tough than the first one we did. So solving this equation with the Cramer rule, solve the equation so we have x plus 2y plus 3z equals 1. So we have 3x plus 2y plus z equals what? 4. And this is a 4. And we have x plus 3y plus 2z equals 0. So now, as you can see, it's a bit intense than the first one we did. So the point is, we have the concept already. So now the same concept, it's the same process, it's applicable to this as well. Using Cramer's Now, what we are expected to do, the first thing we are expected to do is to reinterpret this by saying, you can see. Mr. Cholas, it doesn't work that way. You just have to have it in mind. This is the question. If you check the material, example 13, this is how the question was set. And this is how the question will be set in your exam if you come across this question. Nobody's going to put one for you. But you have to know that when you are solving matrices using the Cramer's rule, when you come across something like this, you have to give it a coefficient. You have to give it, you just have to have it at the back of your mind. It's the essential. So then we may say, as this x is standing alone, they'll represent it with 1. So we bring out this 3. Then this x will give it 1. So this 2 comes down. The 2 comes down. The 3 comes down. Then we have 3. Then we have 1. Then we have 2. Okay, so now we have x, y, z. X, y, z. Then we have 1, 4, 0. So this is the first thing. You know, if it happens to be a pen on paper exam, what you are doing is computer based test. If it happens to be a pen on paper, you're going to be graded for this because the marking scheme is based on solving using the processes. So each step of your solving, each step of your calculation will be graded. So if the total grade score for the question is 10, this already has 2 marks. Yes, it already has 2 marks. So this is the first interpretation. So now the next thing you're having in mind is to solve for the determinants first. So we can erase this. Solve for the determinant first. So we are solving for the determinant first, then we move to the next one. As we are solving for the determinant, then we move to the next one, which is going to be solving for x, which is going to be solving for y as well. So now, to get a determinant, we may then say, where's my marker? Where did I drop my marker? Okay, I think I dropped it here. So determinant now equals, to get, I think we have people joining us now. If you are just joining, you are welcome, but you actually came a bit late. We've done for a less difficult equation, but this is a more intense. This is the difficulty of this is a bit intense than the previous one. Oh, my system might be shutting down soon. Okay, I think we have to rush this. So now, to get the determinant, so we then say, to get the determinant, we go like this. For 1. Get our determinant, we go like this. For 1, let's not forget, there's a plus sign here. There's a minus, there's a plus. So then say, minus 2. Then say plus 3. I have to demarcate this so that we don't get confused. Like this my black marker is gone. So gone now. So let me just demarcate this quickly. Get confused. So now, to get our determinants, just like when we have it in inverse or multiplication of the matrix, we have to do the row 1, column 2, column 3. So for row 1, column 1, we then say when you take this, you are left with 2, 2, 1, 3, 2. We have 2, 1, 3, 2. So now for column 2, row 1, column 2, when you take this, and you take this, and left with 3, 1, 1, 2. 3, 1, 1, 2. 3, 1, 1, 2. Let me see. Okay, Perky, you came a bit late, yeah. But nevertheless, you can always, after the whole thing, you can always come back to the channel to watch the previous, so you can catch up. So for 3, we are doing row 1, column 3. Then we are taking out this. We have 3, 2. We have 1, 3. We have 3, 2, and 1, 3. So without wasting much of our time, just say 1 into bracket. This multiplies this, that multiplies that. This multiplies this, and that multiplies that. This multiplies this, and that multiplies that. So we then say 2 multiplied by 2, that gives us 4. Okay, let me just go straight to the point. 2 multiplied by that gives us 4. Minus 3 times 1, that gives us 3. Then we have minus 2. Then we have 3 multiplied by 2, that gives us 6. Minus 1 times 1, that gives us 1. So we have plus 3. So we have 3 multiplied by 3, that gives us 9. Minus 1 multiplied by 2, that gives us 2. So women, they say, okay, then somebody just joined. Please do well to introduce yourself as you join. So we have 1 into bracket. This is positive 4, and this is negative 3. That should be 1, positive 1, minus 2 into bracket. This is positive 6, and this is negative 1. So this gives us positive 5 plus 3 into bracket. This is positive 9, and this is negative 2. That gives us a positive 7. So we can then say 1 multiplied by 1 gives us 1, minus 2 multiplied by 5 gives us 10, plus 3 multiplied by 7, that should give us 21, if I'm not mistaken. 7, yeah. Okay, yeah, that's 21. So we may then say this is positive 1, this is negative 10. So when you pay 1 naira out of the 10 naira you're owing somebody, that gives you negative 9. Negative 9, when you remove negative 9 from positive 21, that should give us okay, let's remove 9 from 20. That should give us 11. Yeah, that should give us 11. So that's so just give us that should give us 12. So now our determinant is equals to 12. I don't know if this is clear enough. Is this clear enough? Is it clear enough to this extent? Are we on the same page? Please, if you are here to like the video, do well to smash the like button. Oh, Mr. Daniel said, great, awesome. Mr. Jolas, what about you? It's just Mr. Jolas and Mr. Daniel active in the class. What about the 3 other persons? And do well to say something so that we can know you are with us and you are not against us. Perky, is it clear enough? Are you there? Perky, is it clear enough? And the other 2 persons watching us, do well to say something so we can know that we are all on the same page. So now that we have gotten our determinants, no, sir. Hey, how do you want me to start explaining now? Trying to understand. Yeah, I think these people they came late. You understand? I think you guys came late. Do well after the class tonight. Do well to come back and watch the video all over from the beginning. I mean, this we are almost you are almost an hour late already, but just a very quick one. A very quick one. This is the question. This is the equation. This is the equation here. I don't. Okay, let me see. Let me see that question. He said, I don't understand anything here, but you can go ahead, sir. Okay, okay, okay. Let me just a quick one. So that, at least we're on the same page. This is the equation. X plus 2y plus 3z equals 1. 3x plus 2y plus z equals 4. Then we have x plus 3y plus 2z equals 0. Now, we are requested to solve this using Cramer's rule. Now, the first thing foremost is to interpret this equation into a matrix. Interpret this equation into a matrix, as this is the first rule of Cramer. Now, to interpret this equation into a matrix, we then say we are going to treat the element of this equation individually. Now, x here has an invisible coefficient, and the coefficient of x here is 1. It has an invisible coefficient, and that invisible coefficient is 1. So we are going to eliminate x to interpret the equation into a matrix. Then we eliminate x and bring forth its coefficient, which is 1. And that's why you see this 1 here. So don't be confused, don't get lost. That's why we have this 1 here. So we then say 2y, we eliminate its coefficient, which is y, then we'll bring down 2. This 3, which is here, then we bring it down. And the same thing is applicable to 3x. We bring 3 down, then we keep x aside. We bring 2 down, we keep y aside. This z has an invisible coefficient, which is 1, which we have here. The same thing is applicable to x here, which is this. Then we have 3, then we have 2. Now, for this equation, x plus 2y plus 3z equals 1 has x here. Now, this x here is represented with this x. This x here is represented with this x. The x here is represented with this x. So the same thing is applicable to y, which is here, and the same thing is applicable to z, which is here. So now what the equation as a whole is equated to, we have 1, we have 4, and we have 0. So we open another cell, then we put 1, 4, and 0. And we are done with interpreting this equation. Now we have it in a matrix form. Then we can then say, after interpreting this, write the first step. As soon as we are done with the first step, then we move to the next step, which is the second step. I think some persons are ghosting us. I am only seeing messages from Mr. Jolas and Mr. Daniel and Perky. The remaining people, please do well to say something so we can know we're on the same page. So we have the second step, which is finding the determinants of this equation. This equation has to have a determinant to solve for x, to solve for y, and to solve for z. Now, to get these determinants, we have to solve for it. And how do we get the determinants of the equation? We then say row 1 colon 1 we solve for, row 1 colon 2 we solve for, row 1 colon 3 we solve for, and that's why we arrive here. Then we take 1, this one here, we take it here, we solve for it now. Row 1 colon 1 we solve for it, just like we did in when we were solving inverse of matrices, and when we were solving multiplication of matrices. You remember this method when we come here, when we're solving for a row and a column. For example, now we are solving for 1, then we do it this way: we eliminate what we have on row 1 and what we have on column 1. Then we are left with 2 1 3 2. So this 2 1 3 2 is what we have here. So now we are now solving for row 1 column 2, which is 2. And let's not forget we have the sign rule, which is, we are solving for a 3 by 3 matrix. We have plus minus plus minus plus minus plus minus plus. Hope we are together. So now, since it's plus minus plus, then this plus now comes here. As you can see it here, this plus comes here. Then we bring, now we are solving for 2. Then we write the 2 here. Then we rule out row 1 colon 2. So when you rule out row 1 colon 2, we have 3 1 1 2. So that's why we have 3 1 1 2. And the same thing for 3, we have plus. This plus sign comes here. Then we have, when we take this out and we take this out, then we have 3 2 1 3. So we have 3 2 1 3. And with that, we can move forward, and we can then say the multiplication effect can take place, which is this one comes down, that one multiplies up. So now we have 2 multiplied by 2, that gives us 4. So we have 3 multiplied by 1, which gives us 1. Then you close that bracket, you bring down this minus 2, it comes here. Then you multiply this matrix, the element in this matrix, which is 3 by 2 and 1 by 1, which gives us 3 multiplied by 2, that gives us 6. Then 1 by 1 gives us 1. Then we bring out this plus 3. Then we have 3 multiplied by 3, which gives us 9. And we have 1 multiplied by 2, which gives us 2. And let's not forget the signs. And that's how we arrived here. And then we are still treating what we have in the brackets. So we have 4 minus 3 is a positive 4 and is a minus 3. So this positive 4 will definitely supersede the negative 3, because if you are owing somebody 3 naira and you have 4 naira with you, when you give the person 4 naira, you still have a change of 1 naira. That's why we brought this 1 here. So it's a positive 4 minus negative 3. So we have 1. Then we bring out this 2 minus 2. That is still significant. So we say this positive 6, this is negative 1. So it gives us 5. Then we have the 3 plus 3, bring it down. Then we have 9 minus 2 and bring out the 7. I hope we are following. I hope we're all on the same page. I need to adjust my camera a bit. Yeah, I think that's better. So as soon as we go here, this is a positive 1. Per key, are you with us? Are we on the same page? Oh, awesome. I think you are getting it now. Yes, that is very good to know. So now we have this positive 1. When you take it away from this negative 10, then you have negative 9. You understand? So we have this plus sign comes down, then 21 comes down. So we then say negative 9. When you remove it from 21, then what you should be getting should be 12. So now we have only solved for the determinant. Maybe I should write that somewhere here. Okay, now that we have our determinant as 12, let me clear up this space so we can have space to do one or two things. Awesome. 5 persons has liked the video. That's awesome. Thank you for liking the live stream. This is a very good sign that we are actually gaining from the class, and we are finding it very helpful. And please, if you feel this is helpful enough, and you feel it might help one or two persons, do well to share the video with them. Let them also learn, and do well to like and subscribe to the channel if you are yet to do that. So we have our determinant as a 12. So then we can solve. Let me just write that here. Our determinant is 12. Then we have to solve determinant of x, determinant of y, and the determinant of z. So out of all the determinants, we have only solved for the determinant of just the main determinant. So we are solving for the determinant of x, y, and z. So now, to solve for the determinant of x and to solve for the determinant of y, we may then say this is x, this is x, this is for y, and this is for z. Now, determinant of x equals, just like when we're solving the first illustration that we had to substitute for x with this, the same thing is applicable here. Now, if you have to substitute for x, then we are taking out this colon, we are going to represent it with this. As this here, as you can see from the equation, this is x, 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 y, 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 z, z, z. So now, the same thing we did when we were solving for the first illustration, which is not as intense as this, is the same thing applicable in this case. So we may then say, to solve for x now, we'll have to interpret the matrix. We have to reinterpret the equation by saying, now for x, instead of having 1, 3, 1, this is for x, x, y, z. This is not necessary because it's only here, y, z. But I'm just putting here so that for some persons who still don't get it, that they can follow our suit. I think I need to adjust the camera a bit. Yeah, I think it's clearer now. It's better now. Now that solving for the determinant of x, we may then say we are going to substitute this element with what we have here. So it will no longer become 1, 3, 1. It then becomes 1, 4, 0. So for y and for z, it remains. We have 2, 2, 3, and we have 3, 1, 2. Okay. Do we understand up to this length? Do we get it to this length? Are we all on the same page on this? Solving for the determinant of x. Okay, awesome. Mr. Daniel said we are together. Awesome, Mr. Julas, awesome. That's good to know that we are all together. Right on. Oh, thank you very much, Berkey. What about the remaining two persons? Are we all together? I'm just gonna assume we are all together. So we then say we're going to take the first row and the first column. So we're going to be left with 2, 1 and 3, 2. Solving for x, and then say 1. I might have to reduce because I've used some space. And write it up here so I can have that space. Yes, so I can have this space. So we have x, now we have minus 2, and we have plus 3. So we have, if we are to eliminate this, let's take this out and take this out. We have 2 and 1, 3 and 2. So we are doing for 2 now. Then we have this, and we have this. We have 4, 1, 0, 2. 4, 1, 0, 2. So for 3, say this, we have 4, 2, 0, 3. 4, 2, 0, 3. Then we can, we know the next thing to do, just multiply. Then we say 1, that's 2 times 2 gives us, that's 4, minus 3 times 1, that's 3. So we have minus 2. 4 times 2, that's 8, minus 1 times 0, 1 times 1. Anything multiplied by 0 gives us 0. So we have plus 3. We have this gives us 12, and this gives us 0. In another multiplication, anything you are multiplying with 0 gives you 0. So we have that clarified. So we have 1 into brackets. So we have 4 minus 3. This was positive 1. This is a positive 4. Then we have minus 2. Then we have this should give us 8. Then we have plus 3. Then we have this gives us 12. So we have 1 multiplied by 1. This gives us 1. So we have this minus, we bring it down. Then this 2 multiplied by 8 gives us 16. Then I'll bring down this sign. So 12 in 3 places now. This should give us, 12 in 2 places give us 24. This should be 32. Stand to be corrected. So we have positive 1. When you remove it from 16, that should give you minus 15 plus 32, which is equals to, so when we say 15 from 32 now, let's say 15 from 30, that gives us 15. So this should be 17. So now 15 from 32, that's a negative 15 from positive 32 is 17. So I hope it's clear up to this level. I would like to hear from us. Is it clear up to this stage? Mr. Jolas, Mr. Perky, and Mr. Daniel. The other 2 persons have refused to talk, so I don't know their names. They decide to ghost us. So I'll just assume we are all on the same page. Oh, awesome. Mr. Daniel said yes, and Mr. Jolas also said yes. Perky, are we on the same page? So we have that as that. So for determinant x, we have 17. So we can say that x is equal to 17. So now we are going to solve for we are done with x, so it's left with y and z. We are left with y and z. I need to hasten up. I need to increase the pace. Oh, my system will be shutting down soon. It's giving me sign already, so I need to increase. I need to rush things now. But I believe we have understood the concept. It's all about understanding the concept, because these questions can be twisted sometimes. But if you have gotten the concept, then it wouldn't be much of a problem. So so we have for y now. So we are doing for y. So let's interpret this. So x is going to stand, which is 1, 3, 1. So for y, we are going to substitute the element of y. We are going to substitute with what we have there, what the equation was equated to, which is 1, 4, 0. So z stands 3, 1, 2. So we then may say for 1, we have minus 1, we have plus 3, okay, very well, Mr. Daniel said it's clear. Awesome. So now we have for 1, we then do this, then we have 4, 1, 0, 2, 4, 1, 0, 2. So for 1, we do this, we have 3, 1, 1, 2. Now for 3, for row 1 column 3, we do 3, 4, 1, 0, 3, 4, 1, 0. So we'll do the multiplication. Then we should be having 4 times 2, 8, minus 0, minus 1. 3 times 2, 6. And we have 1 times 1, that's 1. Plus 3, we have 3 times 0, 0. We have 1 times 4, that's 4. So we may then say 1 into brackets 8 minus 1 into brackets 5 plus 3 into brackets minus 4. So we have 1 multiplied by 8, that should give us 8. Minus brings down minus, this is 5. This is plus. So we have positive 3, and this is negative 4. So we are going to remove this, my plus sign. It's going to be minus. Then we have 3 multiplied by 4, that should give us 12. Then we say this is positive 8, this is minus 5. Positive 8, negative 5, so this is already 3 minus 12. So we then say this should give us minus 9. So we are good. That's minus 9. So for y, minus 9. So now that's sorry for z. I believe we are all together on this. So solving for z, I think I have to erase this. That too. So for z now. So for z we have this is for z. So we then say x stands 1, 3, 1. Y stands 2, 2, 3. Then z is what we switch, which is 1, 4, 0. So with this we can say for 1, we have this minus 2, then we have plus 1, and we have this. So now for 1, you can see we do our thing, we do this and we do that. So we have 2, 4, we have 3, 0. The same thing applicable to row 1 column 2, where we have 3 and we have 4, we have 1, we have 0. Same thing applicable to row 1 column 3, which is row 1 column 3, we have 3, 2, 1, 3. Then we do our multiplication thing. So we then have 1, we have 2 multiplied by 0, that's 0. 3 multiplied by 4, that's 12, minus 2. 3 multiplied by 0 gives us 0. 1 multiplied by 4 gives us 4. Then we have plus 1. This gives us 9. That gives us 2. So we have 1 into brackets minus 12, close bracket, minus 2 into brackets minus 4, close bracket, plus. That gives us negative 2. You move it from positive 9, that gives us positive 7. So we may then say 1 multiplied by 12 minus 12, that gives us minus 12. Minus, now this is minus 2 minus 4. This is plus, that's 2 times 4, that gives us 8. Then we have plus, that gives us 7. So when we say minus 12 plus, that's 8, that should give us 15. So when we say minus 12 plus 15, that should give us positive 3. And that ends it. That ends it. We are done with solving this equation. And that sums it up for tonight. So z then becomes 3. So that sums it all. So there's one more thing we need to do. That'll be in our subsequent class, which is going to be, for us to cross check. It's also good to cross check. You can just come and anywhere you see s, you had anywhere you see s, you had I think, yeah, for s we have 17. Anywhere you see that this place now to turn into 17. At this place now, this y now becomes, anywhere you see y, it becomes, let me erase that properly. That's what was there before? So okay, we have 2 then minus 9. Then we have anywhere you see z, then you had anyway you see z, then you had what was power z, we had 3. So now this one becomes 3 into bracket 3, and then we carry on. And anyway you see another what's applicable to all of that ones too. So thank you very much, guys. This brings us to the end of this class. Thank you for sticking around. It's very good that we have learned the concept, but that is not enough. We have to practice, as practice will make perfect. So I'm just going to give a very quick assignment. I think there's no need giving an assignment because let me just give an assignment because basically everybody's busy solving their TMAs right now. So giving an assignment might not really respond, but nevertheless, let me just give an assignment for people who might respond eventually. So I'm just gonna give a quick one. Let's go erase the board quickly. Yep. So we have okay, Mr. Mr. Daniel is asking a question. Okay, he's asking a question. He says, solve this 2x plus 3y, okay, through the line point. Okay, that might not be tonight. I think you can forward the question to my WhatsApp. Just go to my WhatsApp directly. I will respond to that. But tonight's class has ended, and system is shutting down in no time. Just send the question to me on WhatsApp directly. I will respond to that. I think that's even close to what we might be taking in the next class. I think we might take that. There are a lot of questions coming out from the TME on that. That might be what we'll be taking in the next class. So, assignment, using Cramer's rule, solve the following. We have 1 x plus 2y equals, let me make it x plus 8y equals 3. Oh, my phone is shutting down. Okay, let me just quickly wrap this up. We have plus y equals 5. Then we have number 2. I think number 2, we have 5x plus 8y plus 4z equals 3. And we have 7x plus y plus z equals 6. And we have 8x plus 2y plus 4z equals 3. So that'll be our assignment. Do well to attend to it and submit it to the class. So thank you very much, guys. Hope the class today was helpful, and I believe we learned a thing or two already. Thank you very much, and I will see you in the next class. Bye bye.